Hello everyone. Today I would like to introduce our accepted paper as a WCV 2002, which is called the Sign Language Translation with Hierarchical Spatio-Temporal Graph Neural Network. And I'm one of the authors, and I'm from Jichao Kan. I'm from the University of Sydney as a research assistant, and I'm also from the University of Technology of Sydney as a PhD student. So just some background, the sign language translation is a task which translates a series of a frame into our natural language. Okay, it's basically a sequence-to-sequence task. It's just combined the computer vision with natural language processing, and it has its own features in contrast with the traditional video captioning process. That is in these tasks, like the appearance and the motions and also the pose of different body parts matters a lot, and especially in this the type of scene. Okay, and the different motions can mean different things, and different appearance can mean different things, and different pose can mean different things. And we can also observe that not only the spatial, the position of these things matters, and the temporal also matters. So that inspires us to use graphic convolutional neural networks in these tasks. This is our architecture. So basically, just as I mentioned before, we just created the three type of features from the video frames, and for each frame we just constructed the appearance features, and then we just have our motion features, and we have our the skeleton or the pose features. Okay, and for these two features we just created, and for each frame we just created one graph, and then we just connected the face and the two hands, all the features and as a graph, and the connections and the edges are the distances. Okay, so and then we just combine a series of graphs across a preset a width of windows to create a temporal, to capture the temporal information. So that is the reason why our method is called spatial temporal. It's just combine these two things. And the same thing for the motion graph. And for the pose graph, the things are a little bit more complicated. So the first thing for each graph, for each frame, we just create the pose, and then we just connect it to have the three the subgraph, and then we just do some the transformation, and then we just use graph pooling to pull all the information into one graph. So that is it. All our graph just capture the spatial and temporal informations, and then we just combine them into one features, and then we just feed it into our decoders, which translate our features into the natural language with our recurrent neural network. So here is our ablation study and some qualitative results. We have the settings. The first one is our baseline without any spatial or temporal information, and the second one is only the spatial, and then only use the temporal, and the fourth one just use spatial and temporal, and this one use all of the information. And you can see our last methods achieve the best result by recognizing all of the most of the glass, and especially in here that is more appearance in here. Okay, so and of course we just did a bunch of experiment to compare with some other methods, and we just achieved some comparable results. And thanks. Do you have any questions?